Okay, so for number 35 and 7.8, they're asking true or false, and they're telling me one is true and one is false.
Well, it says one's true and one's true sometimes.
Yeah, so, and one is sometimes true. So I guess I shouldn't be asking true or false, I should be asking true or sometimes true.
Yep.
Which is a little bit like false, right?
It's a little bit
Broken
false.
clock's right twice a day. This one's going to be right half the time or something. So what I'm interested in is the sign of the arc sine of x always x? Or is the arc sine of the sine of x always x?
I think number 2 is true.
I think number 2 is true.
Yeah.
Where would you go to check?
And attempt.
Yeah, okay, so if you go to the unit circle, right? So here's the unit circle land, right? Where's the issue with arc signing stuff?
When it's not in the first quadrant.
Close.
When it's not in the right half.
Yeah, arc signing stuff lives kind of over here, right? Like this is the
When it's not positive.
this is the place that arc sine. Is that the domain of arc sine?
Yes.
That is the range.
It's the range.
That's the range of arc sine.
So,
You guys see that?
Okay. And then the range of sine.
So when I think about this, right, if I kind of bubble diagram these, this one does arc sine first, and then does sine,
Yeah.
and this other guy does sine first, and then does arc sine.
so that one's true and that one's sometimes true.
Okay, justify.
So if you arc sine first, it's automatically going to give you a certain number between like the range of arc sine, and then if you sine it, it's going to give you back that same number. Versus if you sine something, you could have a number that's outside of the range of arc sine, and once you arc sine, it's going to give you a different number.
Super close, yeah.
What?
You had one mix-up over here in your wording. That was really good. So the justification is this one's always true, and this one's always true because when you apply arc sine to a ratio, that's going to give you like, so this is going to be a ratio, right, that I start with?
Is it because the range
And
of arc
then-
sine is the domain of sine?
Partially, yeah. So the range of arc sine, right, is going to give me something that's a little bit like a reference angle, right? You guys see that? This is going to be some kind of angle, right? And I'm looking at that angle and thinking that's a little bit like a reference angle. It's actually a little bit better than a reference angle because it's not just a reference, it's a signed reference. You guys see that? And then when I calculate the sine of that thing, I'm going to get back to where I started every single time.
Yeah.
Because the ratio for that angle is the same as the ratio for the other angle that I could have been talking
That makes
about.
sense.
You can see that?
Yeah.
So this is bringing me back to a ratio. Whereas on this guy, this is starting with an angle, right?
Yeah. So this could be.
And then it's getting me a ratio. And then I'm getting an angle.
Right, but that's all that angles.
But that angle is really just kind of a reference.
Right. It's not going to ever be something that's larger than 90 degrees.
Yeah, exactly.
And you can put in an angle that's larger than.
Right, like I can put in any angle
like
over
120.
here.
You put 120 over there, and which is the one we just did.
And then-
you get 60 back on the arc sine, which is not x. So.
Yep, so 120 degrees, sine of that is the square root of 3 over 2. And then when we arc sine that,
60.
we get 60 degrees,
Right.
which has the same sign, right? Up, even including signage with a G. Shit. Sign, S-I-G-N. Right, it has the same sign, S-I-N-E,
Plus or minus.
with the same sign, S-I-G-N,
Yeah.
right? But it's not necessarily the same angle. Because that's that kind of reference angle-ish idea.
Makes
That's
sense.
cool with us?
Yeah.
So this is what I would call a one-sided inverse.
Yeah.
Meaning if you apply the inverse function on one side, it works as an inverse function should. And if you apply it on the other side, you get like a funny difference, like a plus or minus, like you do with square roots.
Yeah.
You guys cool with that?
Yeah.
Okay. It should be noted that the square root and squaring function are not even this good. They're not actually one-sided inverses of each other. They're just partial inverses. This thing at least works on one side.